Whoa. Sorry. Oh. Yusuf Mansour. There you are. Yeah. Anybody else just come in? More Kevin?
Then I got 36
Right. All right. Okay, so any leftover questions from chapter 2? I still see too much of this kind of thing here, and you desperately have to be really comfortable solving basic equations, right? If you can't solve basic equations, you really can't do 95% of algebra. I mean, it's all about coming down to solving equations. What we always do, what happens in the real world is we have situations that they use square roots, they use weird trigonometric stuff, and they have equations that manage how is it moving around. And if I can't solve those equations, I can't do anything. Right? So I still see way too much of this. You guys tell me what went wrong here. Something, did anything go wrong there?
Track
Okay.
X one side.
Yeah, be careful now. I made a mistake. This is all on one side. So I've subtracted x twice from one side. I effectively minus 2x from this side and did nothing to that side. That's not allowed. In fact, I don't have to make it this hard at all. What is 4x plus x? And it's all on one side. You can put it together. So what? They're not standing next to each other. But I can add whatever order I want to. And of course I'm going to add the x before subtract the 2 because I can add the stupid x, right? Be really careful about this. I'm seeing that happen a little too often. Any at all is too often. But that's the very basic thing you got to be careful about that will hinder you from being able to solve equations. Both sides of the equation is marked by the equal sign. Cool. Okay. Oh, and one little thing too. I think I made this point when we talked about absolute values. If I have this, what am I taking the absolute value of?
The total number.
Yeah, whatever that number is. And do I know what that number is yet?
No.
No, so I can't take the absolute value of anything yet because I don't even know what that number is yet. So if I say it's this, I've taken the absolute value of a piece of a number. I can't do that. I got to the absolute value of whatever the number is. And what does order operations say? Absolute values are sort of like parentheses. The very first thing we do is whatever's inside the parentheses, right? That will keep you straight. So here I'm supposed to do the inside first. And then what's the absolute value? Negative 2. 2, good. It's not 16. It can't suddenly become 16. So we see that issue with this kind of thing here too. I always get something related to this. Can you guys see what somebody did there?
No.
So they
do it in the parentheses first.
Exactly. Not only is this, I mean, this is not going to work. This is just not the way it works. If I wanted to do something like this, I'd have to write it twice and FOIL it out. Why do that evilness when I can just figure out what the number is that I'm squaring? So again, you do inside first. What do you get? Negative 2. And then you square it. Okay, so that's the way. Beautiful. Positive.
Does that include when the exponent is inside the option?
No, if it's inside the parentheses, then it's a part of that expression inside. It's a part of what you do inside. So if I had this, and I had some other stuff out there, I still do inside the parentheses first, but what do I do inside here first? Exponent, yeah, exactly. Yeah. So now the inside of parentheses becomes its own little problem. And I apply order operations to it. And then I go outside the parentheses, right? Cool. And these are little things that, if they are still problems later, and we've got this other stuff to worry about, I don't want this to be the reason why I'm getting things wrong. I want this to be pretty straightforward. Okay. Oh wow, let's not look at that.
Are you going to do any problems on the test?
Oh, that's why I was asking. Any other questions from the test? Sure.
1G?
All right, so it was something like this here. It wasn't that. But there were 4 different versions of the test, so just to make one up like all of them. 1G for everybody looks something like this, right? So like I just said, what's the very first thing we should do here? In fact, let me do it backwards. What's the very last thing I do here? Subtraction is the very last thing I do. It's totally human for us to go, that's freaking 6. Let me do that. 10 minus 4 is 6. Leave me alone. But it doesn't say 10 minus 4. It says 10 minus something. I don't know what this something is yet, so I can't do 10 minus anything yet. So let me come back the other way. What do I do very first thing? Inside here, beautiful, and then I have to do the exponent inside there first. I like it. So leave everything else alone. And what is 5 squared? 25. Good. It's not negative 5 squared. It doesn't become a plus 25. It's 5 squared with a minus sign on it. Cool.
So it's not negative 5 times negative 5?
Definitely not. If I wanted that to be the way it is, I'd have to put the negative in parentheses, so that I could tell other people, I mean negative 5 twice. This is 5 twice with a minus sign on it. Good.
Okay, that's where I get it wrong.
I like it. Okay, cool. So, I mean, now, what would be the very next step?
21 times
4 minus.
Yeah, this is 4 minus 25 is negative 21.
And then that becomes 21, right?
Good. Absolute value negative 21 is positive 21. But it's what mistake did I make there?
You didn't multiply.
Exactly. So a lot of you guys, I've said this on the homework a lot too. Multiplication cannot become addition. It just can't. So this is still 4 times this. It's just that I know this is 21 now. So you either put parentheses or you put a little dot. That means multiply, right? And now what do I do? Multiply. Because we knew from the beginning I should do the subtraction last. Now I finally know what the hell I'm taking away from 10. 10 minus
84.
84, beautiful. And then that is negative 74, I like it. Cool. Okay. Maybe. Any other questions yet?
Number 6D.
Oh yeah. So this is one like 1G. 6D was something like that. And this happened in more places, but a lot of the time I saw somebody do this. Whoops, that would be really wrong. What's wrong with that? Yeah, because what's the operation right now here? So addition cannot cancel multiplication out. Right? So you always say to yourself, what's the operation that's going on right now? How do I undo that? In this case, it's kind of a specific way to undo it. Bless you. I think I already heard somebody say it. Because when I multiply by a fraction, I'm actually doing 2 things. In this case, I'm multiplying by 14. And I'm dividing by 15, right? 14's up top, 15's down below. So to do both of those opposite, I multiply by 15 and divide by 14. That's why the reciprocal works here. And just don't forget the negative too, right? So if I do negative 15 over 14 to both sides, whatever I do to one side, I've got to do the other one. The beautiful thing over here is everything cancels out. The 15s cancel out. The 14s, the negatives cancel out. That's awesome. We have killed everything over there. The only thing left alive is the x dude, which is exactly what we want. We want the x dude by himself.
Is that you multiply it by the pot?
By the reciprocal. And then, no, you multiply it by the reciprocal, which would be negative 15 over 14, but the negatives cancel. Right, you got to multiply by that negative so that they'll get out of there.
So that part is gone.
So now this is positive x equals, and now over there you can reduce, or you can multiply and reduce, whichever way you want to do it, right? You don't need an LCD there. What's the only time you need an LCD? Add or subtract. When I multiply or divide fractions, I do not need an LCD. Because one part of multiplying and dividing is reducing. Why would I lift them up if I'm going to reduce them again later? Why would I do that to myself? So I only have to get an LCD when I'm adding, subtracting. Then I need like terms. So here I could do 7 goes into 14. 2. 5 goes into 15. And don't forget my negative. Get negative 3 over 2 when I multiply across it. Or you do 7 times 15 over 5 times 14, and you reduce whatever you get. It's a lot easier to reduce first, but you can do it either way. So that's one like 6D. Yeah.
Can I have my test?
Yes, you can. Push in. Oh.
The negative just refers to the top of the fraction.
Say again?
When you multiply by negative 15 over 14, is the 14 not negative?
It is negative, but the two negatives cancel.
Oh, that's what you said.
Cool.
That's what you mean. Okay,
Yeah,
got it.
that's why I had pluses up there a minute ago, because they cancel each other.
Sorry.
That's okay. Yeah.
6 up.
Oh yeah, 6F. If I remember correctly, everybody was either no solution or all real numbers on 6F. All right, there's a gimme. You just got to figure out which one it is. A lot of you guys had a problem like this at one stage, and you would do this, but on the next level there's this. Now, what mistake did I make? How's that x still there? What is 3x minus 3x? 0. And what's that mean? Don't just circle that. No solution, yeah, because that's never true. This works when this works. This never works, so this never works. No solution. That's the idea. Cool. So a lot of times you guys just don't want to let that x go. Teacher's pounding, you're going to get the x by itself. You're like, he wants to leave, don't go. But let him go, because then you can just look at it. Is it true? Also, all real numbers. Is it false? No solution. That's beautiful. Let it go if it wants to go. Yeah. 6G was an equation with fractions in it. So like something like this. And there are many different ways to go. You could still subtract this over, get your x's together, get like denominators, and then cross multiply. I saw a few people do that. Most people try to get them all have the same denominator, but then you weren't really sure where to go from there. The beautiful thing about an equation is I can multiply both sides by whatever I want to, right? Except for 0. In this case, there is a number that is a beautiful number to multiply both sides by, because it makes all the ugliness go away. Why is this equation ugly? It's full of fractions, right? And fractions give us trouble. I don't care what level of math you're at, fractions will give you trouble sometime. So if there's a way to get rid of them, hell yes, I will do that. Just don't overdo it. I can do it here because this is an equation. I could do something to both sides. If I don't have an equation, I can't get rid of my fractions. Too bad. But what is the LCD in this case? 18. So what's he need? 2. What's he need? 6. So now it's 5 over 18 plus 4 over 18x equals 42 over 18x. What happens now if I multiply everything by 18? It cancels out everywhere, right? That's beautiful. Now I've got 5 plus 4x equals 42x. That looks awesome. So every single one you can do that. And this is problem like, I forgot now, number 6G. This is like 6G. So your 6G should look the same form as that. Okay. Is that helpful? Okay, yeah.
I have a question for 5C. Do you FOIL that out, or do you do?
Distribute it? You could. Yeah. Yeah, in fact, that's the way I normally see it done. The very first thing I want to do on 5C is what?
It's move over, it's to multiply the D on both sides.
I love it. Because everybody's 5C was basically the same. I just have you guys solving for different things.
They have 5C. 4C?
Oh, that's right. Some of you guys, I'm sorry. Some of you guys I switched. So it's the one that looks like this. Cool. So it might be 4 in some of you. I can't remember what I did with the different versions. Anytime I'm solving an equation and it's got a fraction in it, I could certainly get rid of that fraction. I don't have to. You could actually work this problem out with the fractions, but this is even worse than a normal fraction problem because these are fractions with all kinds of variables in them. I'd rather, I mean, fractions like this is hard enough. Fractions with nothing but variables in them, no thank you. So the first thing I suggest to do when you have a problem with nothing but letters in it, and there's a fraction somewhere in it, kill it. Get that piece out of the way. So the very first thing, if you said, multiply by D. Now, in different versions, I ask you to solve for C, I ask you to solve for B. From here, you could distribute, subtract them when you don't want, divide by the A, and you're done.
Even doesn't matter what row you're trying to have solve, just multiply by the bottom letter. Is that what you say?
Yeah, yeah. In fact, if I would have asked to solve for D, that's actually the easiest letter to solve for. Well, except for W, because it's already solved for W at the beginning. But if I multiply the D up, how do I solve for D? Divide the W down. I'd be done. Right? But my first step is still kill that fraction, so I don't have to worry about that fraction. Cool. So I saw a few people distribute it. I saw a few people do this. You can divide the A out of the way. The reason you would distribute the A is so that these parentheses wouldn't be there anymore, so you can move stuff around. Well, dividing by the A, you don't need the parentheses anymore that way either. That's another way to get there. If you don't want to do that, you can certainly bring the A in, AB plus AC, and work from there. Cool? So you guys have very concerned looks on your faces. I'm trying to give you a little bit of a head start on your corrections.
Could you actually distribute that for me?
Yeah. All right. What do you get when you distribute the A?
Yeah. Oh, AB.
So if you're trying to solve for C, what would you subtract?
AB.
If you're trying to solve for B, what would you subtract? AC, right? It depends on which letter you're trying to solve for, and that depends on which version of the test you got. So here, just to show you, if I wanted to solve for C, so I'll subtract AB. What is DW minus AB? DW minus AB? I don't know what the hell it is. Don't make it division suddenly. Keep the operation you just did. So a lot of times some of you guys would write the minus, but on the next level it's division. So damn, you almost had it. You wrote it right, and then you wrote it a different operation. It's got to stay this minus that. And then one last step to get c by itself, right? What's the last step? Divide by a. So here's a gimme for a few of you guys.
Does that a cancel that other a out?
Not directly. Because if you have this a on the bottom, can I just cross through those? What's that? What's being divided by a?
BW minus AB.
Yeah, the whole thing, right? They really want to talk to you. That's okay. It's like, how do you make it a super call? A call so you can't hang up. What's being divided by a? If I do this, I'm claiming that only AB is being divided by a. And that's not true. What's being divided by a?
BW minus AB.
This whole thing, both of these things is being divided by a, right? So the only other thing, you could stop right here and you're done. C equals that. Or you could dw over a minus ab over a. You could break it up. Then you could kill the a on that one piece. But you're not allowed to just kill it right now because somehow that dw escapes. Okay. Yes, ma'am.
Oh, go ahead, so you, go ahead.
I'm on hold.
So, what do you do then? Like after that?
You're done. That's my point. This is it. That's why I boxed it off, right?
So you can't, like, so C equals dw minus AB over A.
Yes, cool. That's it. Now, I mean, we get so used to seeing C equals 7. And then we think that this is wrong or we don't like it, but it's really just, it's the same steps. It's just that I can't subtract. If this was 10 and this was 2, I could subtract them, but they're not numbers, so I just have to write them, I just have to keep it like that. That's the only real difference here between solving an equation which is one letter in it versus solving this equation with a bunch of letters. I actually do the same steps. Yeah? 8. B. Oh, so this was just solving an inequality. Wow, I gotta make the whole thing. So most of solving an inequality is exactly the same as solving an equation, right? You still have to distribute, you still have to get your like terms together, you still have to do all that stuff. The only difference is when you divide or multiply by negative, what has to happen? The sign has to switch. Right? And we've already talked about why. It's the best explanation ever. When I divide and multiply by -1, why does the sign have to flip? Because it does. It just has to. It just changes the order of the numbers. This used to be bigger, but now if I divide by negative, it's now smaller than the other one. It's on the other side of the number line. So here, this is exactly the same as solving an equation. What would you do first to solve this?
First you have to distribute.
Yeah, right. We look at the parentheses. We try to free that up so that we're able to move that stuff around. Bring the -5 in.
Negative 5x
X.
plus 35.
Okay. Now what?
Subtract 35.
You could do that, but real quick, 4x minus 5x. Negative x. Let me try this at the same time. Subtract that 35 over. What's 3 minus 35?
Negative 32.
Negative 32, I love it. Right? And what's the last step here?
Divide by x, by negative x.
Divide by negative.
Or you just leave.
Divide by -1. I know I'm not done because do I have x by itself? No, there's a negative sign with it, so I know I'm not done. One last step, how do I make it not negative anymore? You multiply or divide by a -1.
And switch the sign,
And
right?
switch the sign. Why? Because of that. Why? Because you have to. Because when you multiply or divide by negative, the order of which one's bigger or smaller changes. You have to move that sign. Beautiful, exactly. So now to graph this thing, you don't have to start at 0, my God, to get to 32. Just go 31, 32, 33. Which way am I going to shade?
To the right,
To the right. And what symbol am I going to put on the 32?
bracket.
Bracket. Not a parenthesis, it's got that equal sign, right? So bracket, shade up. Thankfully, I didn't see too many people putting infinity on the number line. That, of course, is neat. That's like religion or something. That's like finding nirvana. You can't put infinity on the number line because it doesn't sit. It just is a process. Keep going. But I do have to include infinity when I put my interval notation, right? Because it's got to be from the smallest to the biggest. And is there a ceiling on my house? I can keep going forever up, right? There's no ceiling. It goes forever up. So it goes from what? What's the smallest number x can be?
Bracket 32.
It goes from 32, put a bracket on it, up to infinity. Cool. I like it.
You, on the problems you want it written out like that?
Oh yeah, so this is solve, graph, interval notation. So those are 3 things I needed to see on the test. Cool. Yeah.
7B.
Oh, most everybody on 7B, a lot of people, the mistake you made was you only went halfway around the rectangle. So if you actually draw that picture out, you're less likely to make that kind of mistake. So I think I only took 2 points off for going halfway because you did set up the variables correctly. You just didn't draw the picture that would help you figure out what the perimeter really is. So 7B for everybody was this plot of land. It was something roughly like this or something or other. So if your equation was this 44 or whatever it was, do you see how you only went halfway? So if I got a horse and I like my horse, even though he's got some issues, right? I mean, he's got some major issues. That's a cow. That's a bug. If I only use my fence for this, which is what my equation is saying, this is the point that I really desperately want you guys to understand. Math is not some thing you do in this room and that's it. And it has no connection with the real world. When you write this equation, you are actually saying, I only want to put the wood on these sides. Well, my creature is going to run away, whatever the hell he is. My giant flea, I don't know what that is. If I don't put a freaking fence there, he's going, oh, if he's smart enough, he's going to just turn around and walk the other way. I've really screwed up. So I've got to go all the way around. There's another x, there's another 3x minus 10. I better include all of that in my equation. So my point there is a direct connection between the math that we do and the physical reality of the world. Right there. This equation only covers half of what I'm supposed to. Right? So if you do that job in the real world, you put fencing down and the boss comes over, you might be fired, you don't get paid for that day, whatever. So how should my equation look?
X plus 3.
Yeah, you could either just multiply everything right through. You got to have x plus 3x minus 10. So that's gone this and this. Then I need another x and another 3x minus 10. And that's going to be all my fencing used for those. Cool. Okay.
Can you just multiply it all by 2?
Yes, you could.
Instead of writing it twice?
Definitely, obviously, right? Instead of writing something twice, you can just put a 2 in front of it. You can double it. I love it. So you could just double this and double that. Cool. I just try to get away from perimeter formulas because you don't need any perimeter formulas. You just add up all the sides for the perimeter. Right? You don't need any perimeter formula for triangle, for square, for rectangle. Screw it. They're all the same formula. Add up all the sides. But I know some of us know 2L plus 2W, which is fine. Yeah.
The bonus?
Oh, bonus. All right. What about?
Number 1.
Number 1, it's just you've got to distribute. You got to go from the inside out. Yeah. So the reverse of Russian dolls. You ever seen those dolls that sit inside each other?
Yeah.
With math, you get to work from the inside out. In the real world, you're going to work from the outside in. But we're working from the inside out somehow. So that's number 1. It should have come out to be x to the 4th or negative x to the 4th, something like that.
Maybe 7, 8.
7A.
Or like it.
If I said, let me just say this. If I said, for every quarter in my pocket, I've got 3 dimes. For every quarter in my pocket, I've got 3 dimes. So if I had 1 quarter, how many dimes do I have?
3.
If I had 2 quarters, how many dimes do I have?
6.
What do you keep doing? Multiplying, right? So I saw way too many x plus 3. You don't add 3. If I say for every, for this one it says for every Republican there are 3 Democrats. I know for another one it said for every cup of brown sugar there are 3 cups of oil. Do you see how they're really the same thing? If I call Republicans brown sugar and Democrats oil, I won't get into why that's kind of weird, but do you see how it's really the same problem? One is x, the other one is 3x. You add them together, get the total of whatever it is. Same problem. But I saw way too many people adding. So to me, a big trick for a word problem is put a number in for the thing you don't know, and then see what your brain does. And go, oh crap, that's what I'm supposed to do. So you say, if I had 2 Republicans, there would be 6 Democrats. 3 Republicans, there would be 9 Democrats. Oh, I'm supposed to multiply. That's how I set it up. I'm supposed to multiply. Right? What can x be? Any damn thing you want to. Right? So make it any damn thing you want to and see what you do and then set the equation up.
So it's x times 3?
For, yeah, I don't know, which version do you have?
The Democrat one.
Democrat one, okay. So, yeah, one of them's x, the other one there's 3 for every 1, so it's 3x.
Okay.
Exactly. 3 for every 1 would mean 6 for every 2. It's a multiplication relationship. Good.
It's just the way the words are. Like if it said plus, like how would it, the difference be if you were adding 3 to that?
I would have said for every Democrat there's 3, well, that's a hard one to say the same way. I'd have to say there are 3 more Republicans. Yeah, there's, exactly.
That's just, I got tripped up on the word for myself.
Okay. Gotcha. But I'd have to see that more than somewhere, that there's 3 more of these people than
That
this.
means multiplication. 3 more. Like
3 more means add.
Or add.
Yes, okay. I guess in your eyes that's what you meant to say. So any other questions from the test? Okay. So you can make corrections. It's not due till the day of the next test. Off the top of my head, I can't remember when that is. March 13th? There you go. I do. Okay. So today we're going to get into we've hit the word problem section. We're going to get into this high laziness, by the way. The next level of what troubles people the most is graphing. But if I had a graph, I mean, just to show you an example, average income. I'm going to put something there. So if I had a graph like this, what does that represent?
It's the average. The average is something.
So it's kind of leveling off. Yeah.
You get it broke.
So in 2007, the average income was up here. I have no idea what the average income really is. Let's say it's 35,000. And then here it's down to 20,000. Well, that's kind of a big step. Let's say 25,000. So forth. So obviously we've seen these things in real life. We see them all the time in the news. We see them if you don't watch the news. They even show them sometimes on the Daily Show. You see these graphs all the time. We sort of know how to read them, so they have some reason for existing. In pure mathematics, we learn how to plot points and so forth, so that in the future, when we have real data like this, years versus how much money you made, so forth, so you can see how bad the drop is, and hope to God it starts to turn around and doesn't do something like that, right? That's the current hope, is that it doesn't go. We have to be able to graph them so we can show other people a really quick visual, right? Even beyond just the physical interpretation. Let me ask you this. Let's kind of start this section a little backwards. Let's see. Oh. Okay, let me just write that up there. Now, even before we get into the meaning, and some of you guys have stuff boiling over in your head that you've seen before, like mx plus b and all that stuff, we're not there yet. We're on a very basic level right now. And I'm getting a little ahead of myself just to show you the reason we want to do this whole chapter. How many answers, before I ask that question, can somebody give me an answer? What would an answer look like for this equation? Good. So an answer involves two parts for this, right? Because there are two things I can control here. I have control over both of these. To a point. If I make x 3, then y has to be 3. You guys cool with that? So I think, I'm kind of going off the assumption that we all know how these things look like. If I want to make a point with two parts to it because it's got x and y in it, I can put it together like this. Bless you. Somebody give me another answer for this.
2, 4.
2 and 4.
1 and 6.
We got for 1 and 5. And of course 4 and 2, I can just turn them around, right? 0 and 6.
-1 and 7.
I like it. -1 and 7. Let's get crazy. What about 2.5, 3.5? Whoa, Jeff, slow down there, man. That's crazy. All right, so the point I want to make is how long would it take me to finish this list? Because what have I left out that I really don't want to go? I started doing it there. There's decimals. What about 1.762593, comma, whatever the hell? 3.24, whatever it is. You guys with me? How many answers are there then? Bunches and bunches. Be more specific. An infinite amount of answers here, right? Every single number you can think of, there's got to be a corresponding number to go here to make it come out to be 6. Even if it was 100, I could just make this -94. I can always make it come back to 6, right? Okay. So here's the deal with graphing then. Let me actually see if you guys, how do I graph these points? A number line is not good enough. The good old x real number line is not good enough because it only has room for one variable. And how many variables do we have? 2. So we've chosen then to run the other axis up and down, which makes sense. I want them to relate to how I can move in the real world. In the real world, I can move left and right. Yeah, here we go. And then I can go towards you guys and away from you guys. Right? So I want to involve all these dimensions of movement. And of course, one thing we're not going to talk about in this class is if you come off the board, right? And we're always staying on the board, but you could have a Z piece to this. Oh shit, come on, let's just stay on the board. We'll stay on the board. Right, so we won't get there. So I have to have this other number line running like this. Right, they really are just two number lines. X is already going that way. Y is the latecomer. He's got to go the other way.
What would you do with Z?
Here's Z. Coming up. 3D. See, when I draw on the board, I'm only using 2 dimensions. We have 3. Well, let's stick with 2. I got this beat in my head. This is the most exciting. All right, sorry. So could you plot those points? You know what I mean when I say plot those points. What does that mean? Plot the points. Graph the points. Place them, yes. So what does 3, 3 mean?
Go 3 to the right.
Beautiful. 3 is x, so I want to go 3 on the x-axis, not -3, I want to go positive. and then I want to go 3 up. Not negative, I want to go up. So this controls left and right. This controls up and down. I love it. So I always think about like Etch-a-Sketch. Anybody ever done an Etch-a-Sketch? Do you guys know they exist? You know what I say? What I mean when I say that? So one knob went left and right, the other knob went up and down. And I suck so bad at those, you know, but I'd still play around with it. People can do like the Mona Lisa on there. Shut up. Let me see that. Oh, that's nice. Yeah. So what about 2, 4? Yeah, 2 to the right, 4 up, 1, 5, 1 to the right, 5 up, 4, 2, 4 to the right, 2 up. Let's do something more interesting. Negative 1, 7. It's a little too interesting, maybe. There you go. Back 1, right? Negative 1, back 1, up 7. So remember, the first one is left and right. The second one is up and down. So negative 1, 7. And you see what happens there, of course. Some of you guys are not surprised at this at all. Those points are lining up in a very specific pattern. Right, in fact, they're exactly lining up. They're this line here. Cool. So the first section in chapter 3, though, is really focused on just plotting points, getting used to this, what's called coordinate system. Right? Have you guys heard that before? This is the what's called the rectangular or Cartesian coordinate system. Just to be very technical for a second. Because you can have circular coordinate systems. But we're not going to do those either. Don't worry. We're going to stick with good old X and Y. No Z. All right, how are we doing so far? This should be mostly review. But I desperately want to get you guys to understand why this is so important. To be able to graph, to understand what the hell it is you just graphed, and what do graphs tell you. So here's the cool thing. Here's the connection finally. If I draw this line, pretend it's straight. If I draw that line, I have answered the question. What are the answers to this? It would take me for the rest of my life and all of my children and grandchildren and great-grandchildren, everybody, and they still would be halfway through, to make this stupid list. Instead, I plot a few points, make a line, and say, there's the answer. So the simplest explanation of what a graph is, at the most basic part of it, and actually is the most powerful thing, it is all the answers to an equation in visual form. That's what a graph is. That is almost enough as to why the hell do we do it, right? There's all the answers. I don't want those. Well, find it. Just keep following my line. Find the one you want. Leave me alone. I'm done. Okay, maybe. But let me focus just on section 3.1. Let me make sure I didn't forget something. What are these called? Haven't I broken this up into 4 parts when I cut it like that? Quadrants. And of course quadrants, because like quarters, quadrants, quad, 4. What quadrant is this one? This is the first quadrant. And then it goes, of course, just to be different, they decided to go counterclockwise. This is quadrant number 2. You just put Q2, is that good? Q3, Q4. Okay, so you could see questions like, which quadrant would the point -4, -3, which quadrant would that be in? Because -4, -3, quadrant 3. You don't even have to really plot it. You just have to follow it and see where you would end up. How are we doing so far? Not too bad, right? Okay, good. I was almost going to say something about 3 dimensions, but I won't. Don't worry. So, the very first thing after we talk about just the basics of plotting points, and we went a little further than that, but that was just to give you a preview of what we're doing this for. If I give you an equation like this, how could you get to that point based on what we did earlier? What could you create for yourself so you could actually plot some points, connect them up? Plug in numbers. But you want sort of a format. There's a decided upon format to use, and it's called the little, oh yes, XY table. And really all this is, if you don't like the XY table, that's basically what I was doing earlier when I was doing this. Remember 3, 3, 4, 2 when they equal 6? I was doing an XY table, but I was putting them as points directly. I mean, if you like that better, I don't care. As long as you got your X's and your Y's, I'm a happy guy. But to do it in this format, you pick what you want for X, and you solve for what you get for Y, right? So for example, if I put a 0 in for X, I would get Y is twice 0 minus 1, and get Y is negative 1. Cool. So what point does that correspond to?
Y.
What point does that correspond to? And when I ask you for a point, you've got to give me 2 parts, right? A point has 2 parts. Yeah, it corresponds to the point 0, negative 1. Okay. And you could really plug in anything you want to.
What quadrant will that go on?
Now, that's a tricky one because it's actually on an axis then, wouldn't it be? The point 0, negative 1 would be, do I go left and right at all?
No, you would.
I only go down 1, so I'd be there. So it's like in both of those. So when it's on an axis, you just say it's on the, which axis is that on? The y-axis. Why does that make sense? Because it didn't move left or right at all. So I didn't get away from the y-axis. I stayed on there. How we doing? Okay, so am I good? Yes?
So when you're talking about quadrants, if you look at your example you had before, and it runs into quadrant 4 and 2, but
Oh, you mean like the whole line?
yeah.
Oh, good. So like a shape can exist in a lot of different quadrants, obviously. For the line, I could ask you which quadrant does that line not go into? Then it would be quadrant 3. Right? It'll never go in quadrant 3, will it?
Nope.
It's going away from it there, it's going away from it there. It'll never get in there. But you're right, it's in that one, and that one, and that one. Yeah. But it's kind of unfair then, because it's like in multiple quadrants. And later we can have these curvy deals. Who knows what they're doing? Yeah. Okay, cool. So just to keep going with this. Somebody else give me something I can plug in. 4? So when I plug in a 4, what do I get? 7. Beautiful. I get 8 minus 1 is 7. So I always try to use 0, negative 1, 1, maybe negative 2 and 2. I want to be some negatives, some positives, just to see where this thing is. Because when we start getting to things that aren't straight lines, then I've got to know, okay, when does that thing start to turn? What does it do? Where are the important points? Like what's the biggest it gets and what's the smallest it gets? So what do I get when I put a negative 1 in? Negative 3, right? Twice negative 1, negative 2, minus 1 is negative 3. When I put a 1 in, I get 1. Twice negative 2 minus 1 is negative 5. And twice 2 minus 1 is 3. How are we doing so far? Doing okay? Go ahead and try to plot those points. Try to make your own little graph. If you are messy like me, if I were in my class, I would highly suggest to me that I should get graph paper because I draw very horribly. If you are messy, get graph paper. Okay. So go ahead and try to graph these points on a number line, on a coordinate system, and connect them up, make a line.
I get this from the website.
Oh yeah, good. You can just search Google for graph paper and then just print them out. It's worth whatever the ink and the paper costs you to do that. All right? Just borrow your friend's computer for a minute. Print out 20 things in graph paper. Okay. One thing I haven't said yet, but it's very important. Your scale must be consistent. You can't have 1, 2, 3, 4, and then put a 9 there because the next number you put in was 9. Right? If you think about it in the real world, that would be dishonest. The picture you make would not be true because suddenly it jumps over all this stuff in the middle. That's not fair. So a lot of times people misuse graphs by changing the scale to make it look different what they're doing. Oh my God, look at that huge difference. No, your scale's just freaky. It's not that big of a difference, right? So the more you understand graphs, the more you can't be misled by people purposely making bad graphs. So how do you plot these points here? What points do I have? I have 0, -1, 4, 7, -1, -3, 1, 1, -2, -5, and 2, 3. See if it made go down a couple more there. Okay. So 0, -1, like we said, it doesn't go anywhere left and right. It only goes down 1. How about 4, 7? So 4
To the right.
good on the x-axis, and then 7 up. The uncool. It's that commercial tool. -1, -3.
1 to the left. 1, 3 down.
And then 3 down. Good. 1, 1. 1 over, 1 up. You can't go wrong there. -2, -3. So now I go 2 back. Am I looking at it right? -5.
-5.
Yeah, I love my writing. -2, -5. Cool. And finally, 2, 3. Yeah. And look at that. Especially when I made them big. Everybody's fine. Good. So right now, these should be straight lines. The key is, in fact, we've had a question like this already. What makes something not linear, not a linear equation, is if one of my variables has some other power than 1, has like a square on it, a cube, square root, something freaky like that. That's when I start getting curves. If they're linear, if they're to a first power, it's going to be a straight line. One's not growing a lot quicker than the other one. They're both kind of growing at a nice even pace. Okay, how are we doing so far? Some of you are bored out of your mind. That's good. Some of you kind of know your graphing already. I love it. Just enjoy it while you can. I'm trying to go slow because a lot of people have trouble with graphing. Here's the last kind of question you would see in this section. See if you guys can do this here. What would you do with this?
Solve for x.
After doing what? Beautiful, right? And that's what you meant.
Yeah.
But what is it that you know from this point that I've given you? You know what? You know y is -2, and this is, I didn't even put a question, I didn't have to. They're asking me, what the hell's supposed to go here? What is x when y is -2? Oh, let's find out. You're a little ahead of me. So, what do I do then with this? So this is exactly like the earlier question when they have like a plus b squared minus c. You know, what is it if a is 2 and c is 3 and b is -4? You start plugging it in. So I know that y is -2. And now I can solve for x. Cool. So now it's back to what I was saying earlier. I don't care if you're graphing. There is going to be some solvent equations in there somewhere. Solvent equations can make their way into almost anything we do, because we need to be able to do it to solve some of this stuff. So now I've got add the 6. Good, divide by -7. Here's a good example of they're not always pretty, right? Would I want to graph that? No. But if I had to, what would I do? What is negative 8/7? It's negative 1 and 1/7. So you just put the dot a little bit beyond negative 1, right? Doesn't have to be perfect. Don't worry, you're not going to be asked to do a lot of plotting fractions. Don't worry. Cool? Okay, so in this first section, it's very basic. It's just plotting points. They talk about quadrants. They give you XY tables to fill in. And they give you some with missing parts of points. So this first section shouldn't be anything too evil yet. Now let me ask you this. Do you want to take a break right now, or do you want to keep going a little bit further?
Go ahead.
A little further? All right.
Yeah.
Leave early, no break.
I like that. Okay, let me make sure is he doing that? Yeah. Oh, he's almost done. Okay.